Welcome, curious minds. Today we're diving deep into something really fundamental to our connected world. It's a piece of tech that often just works quietly in the background. We're talking about the I2C bus market.
That's right.
Think about your smartphone, your car, maybe even your smart thermostat at home. This quiet little communication system is right at the heart of how they all work.
Absolutely spot on. The I2C or inter-integrated circuit bus, it's essentially a key communication pathway for electronics. It lets different little chips, microcontrollers, sensors talk to each other inside a device, and it does it really efficiently just using two wires.
Two wires, amazing.
Yeah, and its importance has just, well, exploded with all the smart devices, the Internet of Things. It's become this sort of silent language making our tech tick.
Right. So our mission for this deep dive is to unpack the impressive growth path of this vital tech. We
Yeah.
want to pinpoint where that growth is happening most dynamically across the globe and really get a handle on what this quiet revolution means for, well, our increasingly connected future. Okay, let's unpack this. So let's start with the big picture then. Even though this I2C bus works mostly unseen, it's actually a surprisingly big economic force. And here's where it gets really interesting.
Oh, it absolutely is. When we look globally, this market back in 2021 generated over $6.2 billion. That's billion with a B.
Wow. Okay.
Yeah, 6,248.26 million to be precise. But that's just the start. It's projected to grow to over $8.1 billion, 8,169.7 million by 2025.
Okay.
And then it really takes off. It's forecast to climb to nearly 14 billion, 13,966.9 million by 2033.
Almost $14 billion. That's huge.
It is, and that represents a pretty solid compound annual growth rate, or CAGR, of 6.933% over that whole period. And look, this kind of steady decade-long growth, it isn't stemming from just one niche area. It really shows how widespread I2C adoption is, pretty much across every modern sector you can think of. Consumer electronics, definitely.
Yeah.
Complex automotive systems, critical healthcare devices, and the whole huge landscape of industrial automation.
It's really quite astonishing, isn't it, when you stop and think about how many smart devices you interact with every single day. Your watch, your car's dashboard, the
The
TV.
hits.
It makes you wonder just how many of these little I2C interfaces are silently connecting all the bits inside.
Exactly.
It really speaks to its critical role, even if we don't see it. Now, that's a powerful global view. But I'm curious, where are the particular hotspots? How do different regions stack up in this global growth story? What makes some areas, grow faster?
That's a great question. Because while the growth is global, there are definitely regional leaders, and each has its own kind of drivers. Let's start with North America. So that region brought in over $2.1 billion, $2,149.4 million back in 2021. And it's expected to more than double, hitting over $4.5 billion, 4,539.24 million by 2033. That's a steady CAGR around 6.43%.
Okay, solid growth.
Yeah. And the U.S. naturally takes the biggest slice of that pie, about $1.75 billion in 2021, growing to over $3.6 billion by 2033. That's driven by, strong innovation in consumer tech and a really robust auto sector.
Right.
But interestingly, Canada actually shows a slightly higher growth rate, 7.218% CAGR, so it shows pretty broad adoption across the whole continent.
Got it. So strong across North America, but Canada's growth rate is notably high. What about across the pond in Europe?
Right, moving to Europe. That market was valued at over $1.8 billion in 2021. So $1,818.24 million. It's set to reach nearly $3.9 billion, 3,896.77 million by 2033, expanding at a, again, solid 6.6% annual growth rate.
Okay, similar pace to North America overall.
Pretty similar, yeah. But Germany really stands out here. It's projected to more than double its market size by 2033. It goes from about $345 million to nearly $800 million, with a very strong 7.34% CAGR.
Wow. Germany's really pushing ahead there. Why is that?
Yeah. And other big economies like the UK, France, Italy, they also show consistent, healthy growth, usually around 6% to 7% CAGR annually. The UK, for instance, is heading towards $622 million by 2033. France, about $460 million. Italy, around $430 million.
Okay.
Russia, however, shows a bit of a slower growth rate comparatively, about 5% CAGR,
Right.
likely reflecting different market dynamics, maybe investment priorities in electronics there.
Yeah.
And we also see consistent expansion in places like Spain, Sweden, Denmark, Switzerland, pretty much across the board in Europe. CGR is between, say, 5.5% and 6.6%.
So Europe's strong and steady, led particularly by Germany's industrial might. What about Asia Pacific? You hinted hinted that was a big story.
Oh, yeah. Asia Pacific is, well, what's fascinating there is just the sheer velocity of the growth. The region was about $1.3 billion, $1,287.14 million in 2021. But it's expected to absolutely skyrocket to over $3.2 billion, $3,254.29 million by 2033.
Wow. More than doubling, too.
Exactly. And that makes it the fastest growing region globally. We're talking an impressive 8.045% CGR overall for APAC.
Over 8%.
Yeah. And this isn't just about the numbers. It reflects this massive digital transformation happening there. China, for example, leads APAC in sheer size. Its market's projected to nearly triple, going from about $385 million to almost $1 billion by 2033. That's an 8.245% CAGR.
Huge numbers from China.
Huge. But the real standout in terms of growth rate is actually India. India shows the highest growth in the entire region, maybe the world, for this market, posting a staggering 9.019% CAGR.
Over 9%. What's driving that in India specifically?
It seems to be a direct reflection of, well, several things. Aggressive government initiatives pushing Make in India, boosting local manufacturing. Plus, rapid urbanization, a growing middle class demanding smarter consumer gadgets, and more robust industrial solutions, too.
Okay, but perfect storm for tech adoption.
Kind of, yeah. And beyond China and India, you've got Japan expanding strongly to over $500 million by 2033, South Korea reaching over $220 million, Singapore jumps significantly, too, from about $50 million to over $130 million. And the whole Southeast Asia region, as a block, sees really high growth, too, like 8.7% CAGR, hitting nearly $230 million by 2033.
Wow.
Yeah, and briefly, places like Taiwan, Australia, the rest of APAC, they're also showing strong performance, mostly around or above 7% CAGR. It signals this broad, rapid embrace of connected tech.
Okay, so Asia Pacific is definitely the engine room for growth here, particularly China and India. What about the other regions? South America.
Right, shifting focus to South America, we see a market that was worth over $440 million, 443.6 cents in 2021. It's forecasted to more than double as well, hitting over $1 billion, $1,022.66 by 2033. That's a robust 7.195% CAGR.
So faster growth in North America or Europe overall.
Exactly. Brazil leads in market size, going from about $166 million to over $376 million. But again, interestingly, Argentina actually shows an even higher percentage growth rate. 7.791% CAGR indicates a significant uptick in tech adoption there, too.
Interesting dynamic.
Yeah. And other nations like Colombia, Peru, Chile, they're all on a solid upward path as well, projected to cross the $100 million mark each by 2033, with growth rates mostly between 6.7% and 7.5%.
Okay, strong growth in South America. How about the Middle East?
Middle East, another region showing strong growth. It accounted for nearly $350 million, 349.9 MEBers in 2021, and it's projected to reach almost $800 million, 798.4 M by 2033, growing at over 7% annually, 7.103% CAGR.
Again, outpacing North America and Europe.
Yep. Saudi Arabia continues to lead, expected to go from about $91 million to nearly $210 million. That's likely driven by its big diversification plans, smart city projects, Vision 2030 stuff.
Right, those major initiatives.
Exactly. And the UAE also records really impressive growth, nearly 7.8% CAGR, 7.782%. It's pushing hard on its own tech advancements and infrastructure. Turkey's also significant, reaching about $147 million by 2033. And places like Egypt, Qatar, the rest of the Middle East show steady momentum too, generally averaging 6-7% growth.
Okay, so strong momentum there too, particularly UAE and Saudi. Lastly, Africa.
And finally, Africa. The continent saw about $200 million, 199.99 in revenue in 2021. It's estimated to more than double to over $450 million, 455.46 MNs by 2033. That's a solid 6.475% CAGR.
Okay, similar overall growth rate to North America.
Roughly, yes. South Africa leads this growth, expected to go from about $81 million to nearly $200 million. Nigeria is also growing significantly, reaching about $87 million by 2033. And the rest of Africa collectively is projected to hit about $170 million, though its combined CAGR is a little lower, around 5.7%. It shows increasing digitization, growing demand for these embedded systems, but perhaps starting from a smaller base or with different development timelines in some parts compared to other regions.
That is a truly comprehensive world tour. And it's striking, isn't it? You see this diversity in growth rates, yet this really consistent upward trend pretty much everywhere. So when we put all this together, what's the fundamental takeaway? Why does this widespread and a kind of silent growth of the I2C bus truly matter for our future?
Well, I think it's clear, right? The I2C bus market is undergoing this really dynamic, pervasive growth across every single region. And this relentless expansion, it's not just, some statistical quirk. It's a fundamental sign of how deeply integrated and, well, smart our world is becoming. The drivers are undeniable. It's the constant advancements in smart devices. It's the growing complexity of cars, the boom in wearables, the spread of IoT into everything from homes to factories. And while North America and Europe keep innovating strongly, the
Sure.
sheer speed we see in Asia Pacific, especially India, China, Southeast Asia, that's a really powerful signal about maybe emerging global tech leadership. And importantly, we're seeing these emerging markets, South America, the Middle East, Africa, they're catching up fast,
Yeah.
fueled by digitization, big infrastructure projects.
So it's becoming truly globalized, this core tech.
Exactly. This isn't just about market dollars. It's like a quiet testament to how everything around us is becoming more modular, more interconnected at its very core.
That really does raise a fascinating point. Are we moving beyond just having isolated smart devices towards environments where almost everything can communicate, maybe even anticipate? This deep dive really puts into perspective just how vital these unseen components truly are. Thank you so much for joining us on this exploration of the IDC bus market. We really hope this has given you, the listener, a bit of a fresh perspective on the everyday gadgets around you. Maybe next time you pick up your phone or start your car, you'll ponder that intricate, silent communication happening just beneath the surface, making our smart world actually possible.
Welcome back to the deep dive. Today, we're really getting into the weeds with the I2C bus market. That super common two-wire system that's kind of hiding in plain sight in so much of our tech. Yeah, our mission here is basically to cut through the technical jargon using the great material you shared and give you the quick scoop on how this fundamental piece of tech works and why it's still so incredibly important. Think of it as your shortcut to getting smart on a really critical bit of digital communication.
It really is fundamental. You're right. I2C, that's integrated circuit. It's it's just a cornerstone for embedded systems, anything where components need to talk to each other. And the beauty of it, it's not just simple, it's like elegantly efficient. Think about it, just two lines, two wires, SDA for data, SCL for the clock signal, that's it for potentially dozens of devices. It's almost counterintuitive in a world chasing more is more. I2C really succeeds by doing less, but doing it well.
That elegance, that simplicity sounds like its main advantage. So, okay, where is this advantage really making waves? What are the big, compelling forces pushing the I2C market forward right now?
Well, one massive driver is definitely the huge boom in embedded systems and microcontrollers. I2C's simplicity makes it a perfect match for microcontroller environments. You look at the explosion of IoT gadgets, wearables, smart home stuff. They all need components talking to each other without adding complexity or, taking up space. I2C is vital there, letting them swap data quickly and efficiently in those really tight, compact designs.
Right. And it's not just the fancy new IoT stuff, is it? I mean, this tech is deep inside everyday things, too. Consumer electronics, cars,
Yeah.
your smartphone, your camera, the screen in your car, lots of sensors talking, different parts integrating. I2C is often the glue holding that communication together. And it seems driven by our demand for, well, smaller, lower power gadgets that just connect seamlessly.
Exactly. And stepping back a bit, another huge factor is just how cost-effective it is for connecting multiple devices. That two-wire architecture, SDA for data, SCL for the clock, lets you hook up lots of slave devices to a single master. It's incredibly efficient in terms of space on the circuit board and the actual cost of materials. Think about designing, say, a wearable heart monitor or a drone or even industrial sensors. Every millimeter, every penny counts.
Huh.
I2C. Still very appealing for keeping layouts clean and costs down.
Okay, so it's a real workhorse, saves space, saves money, makes a lot of modern tech possible. But like anything, can't be perfect, right? What are the roadblocks, the significant challenges for I2C?
That's a really important point. A major limitation is definitely its speed and distance. I2C isn't built for speed, not like, say, SPI, which is faster for point-to-point, or UART, which can go longer distances. So for really high-speed data transfers or communicating over more than a few meters, I2C struggles. That naturally limits where you can use it, especially in high-performance computing or some industrial settings needing real-time speed over longer cables.
That speed cap makes sense. But what about reliability, especially with all those devices sharing the same two wires? Does that cause problems like bus contention or errors?
It absolutely can. If you've got multiple devices trying to talk on those shared SDA and SCL lines, things can get messy. If one device goes bad or starts, hogging the line, it can potentially jam up communication for everyone else. So without solid bus arbitration, that's the system for devices taking turns politely and good error checking, you can definitely run into communication breakdowns or delays. It's like a conference call where everyone tries to talk at once, or one person has a terrible connection. In critical systems, that's obviously a big concern.
Yeah, that party line analogy really paints a picture. And I heard there's another potential headache for designers, something about voltage levels.
Ah, yes. Voltage level compatibility. That's a common design challenge. You see, different chips might run at different voltages. Maybe one runs at 3.3 volts, another at 5 volts. Classic example. To get them talking reliably over the same I2C bus, you often need extra components called level shifters to translate the signals between those voltages. It's doable, of course, but it adds complexity, adds a bit of cost, and takes up more board space. It's just another thing engineers need to factor in, especially when mixing older and newer parts.
Okay, so we have these known limitations, speed, distance, potential for traffic jams, voltage issues, and yet I2C is clearly not going anywhere. So what's keeping it relevant? Where are we seeing innovation or new adaptations?
Well, what's really interesting is how critical it's becoming in these sensor-heavy applications. We're seeing I2C as the go-to for building sensor networks. Think environmental monitoring systems, complex gesture controls on devices, smart medical wearables. Its ease of integration is just fantastic. Developers can basically just plug in various sensors, temperature, pressure, motion, whatever, using the standard interface. It lets them build intelligent platforms really quickly in fields like healthcare, automation, smart homes, without needing a custom solution for every single sensor.
And that definitely connects to the mobile world too, right? The need for low power, battery operated devices must be a huge plus for I2C.
Oh, absolutely. That's a major growth area. I2C is incredibly well suited for things that need to sip power and run for ages on a battery. Its idle power draw is very low, and the communication itself is pretty efficient. So your fitness tracker, remote sensors out in a field, wireless nodes in a building, all that stuff benefits hugely. As everything keeps going cordless and mobile, I2C's energy efficiency makes it more and more relevant.
Right, endurance is key. And it sounds like it's not just sticking to small gadgets either. It's pushing into tougher environments too.
Yes, definitely. We're seeing I2C gaining more ground in automotive and industrial IoT sectors as well. It's getting embedded deeper into the intelligent modules that drive modern cars and factories. Things like onboard vehicle diagnostics, climate control sensors, even real-time control systems in some industrial settings. The big push towards smarter manufacturing industry 4.0 and more connected, feature-rich vehicles, that's really boosting demand for cost-effective modular ways to connect components. And I2C fits that bill nicely. It's often the quiet enabler behind a lot of that smart functionality.
So, wrapping this all up, the big picture seems pretty clear. The I2C bus market keeps growing strong because fundamentally it's simple, it's affordable, and it scales surprisingly well for many tasks. It's this foundational tech that just keeps adapting.
Yeah, even with those technical limits we talked about, its role keeps expanding consumer gadgets, healthcare, automating industry, making cars smarter. It's really cemented its place in how embedded systems communicate. Exactly. And maybe here's a final thought for you, the listener, to chew on. In this world that's always demanding faster speeds, more complex connections, more bandwidth, how does something fundamentally simple like I2C keep finding new ways to be relevant? Could its simplicity even, perhaps, inspire totally new ways of thinking about communication for all the tiny, interconnected devices coming our way?